Hello there, sheet metal super technicians. This is your friendly neighborhood A&P, Jay Harbert. And this video we're going to focus on using our drawings, and this is actually the first project that you'll need to complete in the lab. Now a drawing, there's a lot of data being presented. It's important that when it comes to drawings, we kind of learn a system of looking around. We definitely want to look before we leap. In this case, let's start with the notes. A note is a way that an engineer can speak directly to you. Notes are kind of a side conversation. They're important enough that they're pointed out on drawings or added to drawings to get your attention. So generally when I look at a drawing, yes, there's dimensions, there's shapes, there's materials, but one of the first things I want to do is take a quick look at my notes. Now, the first note I read here states to cut 4 sheets. Well, there's a critical piece of information. I know exactly how many I need to cut, and these sheets need to be slightly larger than nominal size. Well, this term right here, nominal, is an important term when it comes to using drawings for any purpose. Nominal simply means the perfect size. Nothing added, nothing taken away. The exact size. Well, if we look out here on the plans, we have 3.13, 3.13, yet there's another note here that states cut square slightly larger than 3.125. That'd be the same as 3 1/8 by 3.125, and then file to a nominal size. So what are we being told to do? We would take our ruler and lay out 3 1/8, and then we're going to add just a little bit to it. So for example, if I was using this scale, I wouldn't go to exactly 3 1/8 of an inch or 3 4/32. I would go slightly larger. I'd say probably 2/32 larger. And what we're going to end up with is a square that's only about a 1/16 larger. Then we could file to make sure that we get down to the exact size. See, if we put our minimum size of 3.125, we cut this exactly on that, yet there's a slight error and our line gets cut a little bit to the inside. Now our sheet metal pieces will not be large enough. So it's critical that we often start looking at notes and start to get an idea of what we're meant to do. So we're going to cut 4 sheets slightly larger than 3 1/8. I'm going to cut for, I would say, 3 3/16 of an inch. Well, on our rulers, well, they're not broke down in 16ths. They're broke down in 32nds and 64ths. So let's set aside a minute and let's take a look at how we could handle that. A 16th could convert to a 32nd. How? Well, 32 divided by 16 is 2. 2 times 3, well, by golly, we have 6/32. So I could cut using the scale that I'm using in 32nds, 3 6/32 of an inch. If I make all sides that dimension and I cut them, it leaves me a tad of border in case there's a slight error, and then I can file very quickly, very efficiently to our nominal size. Now here's our second note. Use a square to ensure that the corners are 90 degrees. So we've got squares in our toolbox and squares laying around the shop. What this person is telling me, we need to make sure that all of these are perfectly square shapes, and in order to do so, let's actually get a tool out when we lay out these lines. And then finally, the third note here is to file edges to a final size and to a smooth finish. So what they're saying is, let's bring our slightly larger sheet into that nominal or perfect size, then let's take that file and make sure there's no sharp edges. That doesn't mean radius the corner. What that means is take any burrs off these long edges. We want to keep our edges nice and smooth. If the corner was meant to be radiused, they would give us some information on this drawing and identify the radius, but they don't. So what they mean is we're just to break all the sharp edges so that all of our pieces are smooth and will lay flatly together. Now here's some more information we can look at. Right here it's calling out once again, as it did in the note, 4 pieces. This is their nominal size, but the note says cut them initially slightly larger. This is to be made out of 2024 T3 aluminum, which is what we'll have available in our lab. It's to be a 40 thousandths thickness. That means any other thickness won't do. So we would start our first project by reading these notes, formulating the picture of what's expected of us. And then the next step is to select the correct material and the correct tools to create these 4 pieces. Now that's a basic walk through this drawing. This is the first project in your sheet metal lab, and hopefully this little discussion will help you get off to a very fast and very successful start. And until next time, do good work and be safe.